Big data and its tools. Big data refers to extremely large and complex data sets that cannot be effectively processed, managed, or analyzed using traditional data processing tools or methods. These data sets typically encompass vast volumes of data that may come from various sources, including structured data, such as databases and spreadsheets, semi-structured data, like XML and JSON files, and unstructured data, such as text, images, and videos. The term big data is often characterized by the three V's: volume, large amounts of data; velocity, high data generation and processing speed; and variety, diverse data sources and types. Additionally, some models include other V's like veracity, data quality and trustworthiness; and value, the potential insights and value that can be derived from the data. Big data tools. To manage, store, process, and analyze big data effectively, a variety of tools and technologies have emerged. These tools are designed to handle the challenges posed by the volume, velocity, and variety of big data. Below, I'll discuss some of the key categories of big data tools and provide examples of specific tools within each category. Data storage and management. Hadoop Distributed File System, HDFS. HDFS is a distributed file system designed for storing and managing vast amounts of data across a cluster of commodity hardware. It is a core component of the Hadoop ecosystem. NoSQL databases. NoSQL databases like MongoDB, Cassandra, and Couchbase are well suited for storing and retrieving unstructured or semi-structured data in a flexible manner. Data processing and analytics. Apache. Hadoop is an open-source framework that includes the Hadoop Distributed File System (HDFS) and MapReduce, a programming model for processing and generating large datasets. Apache Spark. Spark is a fast and general-purpose cluster computing framework that supports in-memory data processing. It is commonly used for iterative machine learning and data analysis tasks. Apache Flink. Flink is a stream processing framework for real-time data processing and event-driven applications. Apache Kafka. Kafka is a distributed event streaming platform used for building real-time data pipelines and streaming applications. Data integration and ETL. Extract, transform, load. Apache Nifi. Nifi is an open-source data integration tool that provides data ingestion and data flow management capabilities. Talend. Talend is an ETL tool that enables users to connect, extract, transform, and load data from various sources to data warehouses or other destinations. Data visualization and business intelligence. Tableau. Tableau is a popular data visualization tool that allows users to create interactive and shareable dashboards to gain insights from big data. Power BI. Microsoft's Power BI is another business intelligence tool for visualizing data and sharing insights with stakeholders. Machine learning and AI, TensorFlow and PyTorch. These are open-source libraries for deep learning and machine learning. They are widely used for building and training AI models on large data sets. H2O. AI H2O. AI provides an open-source machine learning platform for big data, making it easier to develop predictive models at scale. Data governance and security. Apache Ranger. Ranger is an open-source platform for managing security and compliance policies in a Hadoop ecosystem. Cloudera Navigator. This tool helps organizations track and govern their data assets, ensuring data security and regulatory compliance. Real-time data streaming. Apache Kafka. Besides its use in data integration, Kafka is a popular tool for real-time data streaming and event processing. Distributed computing and containerization. Docker and Kubernetes. These technologies enable the deployment and management of big data tools and applications in a scalable, containerized environment. Search and indexing. Elasticsearch. Elasticsearch is used for full-text search, analytics, and log monitoring. It is particularly helpful for searching and analyzing large volumes of textual data. These big data tools and technologies are constantly evolving to meet the growing demands of data-driven organizations. Selecting the right tools and technologies depends on the specific requirements of a given project. including the size and nature of the data, processing needs, and the desired outcomes. Effective big data solutions often involve combining multiple tools and technologies to create a comprehensive data ecosystem.